Question number 18. A lamp is suspended in equilibrium from a fixed support by three long identical wires. The weight of the lamp causes each wire to have an extension of 0.4 centimeter. So it is already given when you put three wires like this, the extension that you get here is going to be 0.4 centimeter. Okay. The height h of the lamp above the wire is measured. The middle wire suddenly breaks and the lamp falls a small distance as the extensions of the two wires increase. Now what we will do is, let us start solving case by case. Now first let us take three wires, 1, 2, 3. Okay, I have not read the full problem, but anyway let us solve this now. So I put the lamp over here. So therefore each wire is said to have a tension T. 3TW will be equal to W, and we know tension equal to Kx. So 3 times Kx1 is equal to W, or X1 should be equal to W by 3. We got this one. Second case, what happens? There are two wires only connected, third wire is broken down. So I have a lamp once again suspended. So T here and T here acts. So therefore, now what happens over here? So 2T will be equal to Kx2, which is equal to W. Sorry, 2T is equal to W, or T should be equal to W by 2. But T we already know it's Kx2. Kx2 is equal to W by 2, or X2 should be equal to W by 2. We got all this now. Now let us read the question. This wires obey Hooke's law. We have put that. When the lamp is in equilibrium, the height h of the lamp above the floor is measured again. Okay, we measure the height. What is the difference between the two values of h? Okay, now let us say this is the ground. Okay, and now what we do is we measure what is this height. We measure this height. Let us say this is h1. Okay, when you put two wires, then what can happen? The lamp is now seen to be hanging over here. Now this is your h2. Now he is asking you what is h1 minus h2. That's it. Okay, so in essence, what you can say now is that if I find the extension due to the first three lamps is x1, and only due to two wires, that is it extends more, then it is x2, then x1 minus x2 will be equal to h1 minus h2, because you know x1 plus h1, see, I will repeat it once again, x1 minus x2 will be equal to h2 minus h1, right? Sorry, h1 minus h2. This will be seen. The reason is because when I add these lengths, okay, so x1 is larger, sorry, x1 is smaller, right? So it will be x2 minus x1. Okay, x2 is larger, and then h2 is smaller. But x2 plus h2, I write it down here. x2 plus h2 will be equal to x1 plus h1, right? So therefore, I can always write x2 minus x1 is equal to h1 minus h2. Because we do not know what is the actual height, so we cannot determine h1 and h2 separately. But this is equal to the difference of the extensions. I can always find out x2 and x1. How do I find? Look at this here. The x1 and x2 are already known to us. Okay. So if I am able to express, now this value of x1 is already known to me. How much is it? 0.4 centimeter. This is known to me. W by 3k is known to me. Now what is W by 2k? You find out and then you express that one. Simple. Now what I do is, from here I will do W by k is equal to, I will push this 3 that side, which will be 1.2 centimeter, right? 3 into 0.4 will be 1.2. So therefore here what I will do, I will write x2 is equal to half into W by k, right? So what is W by k? 1.2. So now this should now be equal to half into 1.2, which will be equal to 0.6 centimeter. Okay. So I have got the value of x2, I have got the value of x1, right? What do I need? x2 minus x1. What is x2 minus x1? 0.6 minus 0.4, which is equal to 0.2 centimeter. Where is 0.2 centimeter? Answer is simple. Okay.